So hi, I'm Charlie Calvert. I'm the C# Community PM, and I'm here today with Sam Ng and Chris Burrows, two devs on the C# team who helped create a lot of the new features in C# 4.0, particularly the dynamic feature, which is what we're going to talk about here today. So, Sam, why don't you just introduce yourself briefly, tell us a little bit about who you are.
Sure. So my name's Sam. Like Charlie mentioned, Chris and I both work on the C# compiler team. So we're responsible for a lot of the new language features that we've been working on. We get to participate in the language design as well. So we get to try to help shape the language features as well as implement them. We do a lot of work with a lot of partner teams. For the main one that we'll talk about today is a DLR. They're pretty heavily involved in the dynamic feature that we'll be discussing. But yeah, that's me.
Chris?
And I'm Chris Burrows. I'm a compiler dev, and everything that Sam just said applies to me too.
That's perfect. So let's go ahead and just dive right in here. So we have this new feature in C# 4.0 called dynamic, and why did we add that to the language? I mean, C# has always been a strongly typed language. Why do we suddenly add something called dynamic? It seems contrary to what you would expect from C#.
So it's interop. Interop is the story, and interop is the story I think for all of our C# 4 features, or many of them anyway. Trying to make your life better because you don't always program against APIs and data models that are in C# or .NET or anything. And so dynamic allows you to interop with dynamic languages, with Python and with Ruby, and with dynamic object models. Think about like DOMs and things like that. Like in Silverlight, you might access the DOM a lot. You have no type information about the objects in the DOM. And with COM and Office are not always strongly typed. So this helps there too. And aside from, I think that's the primary reason. That's the primary goal of introducing dynamic to the language. It is an interop feature, but it also doesn't have to be. You can also use it to write code against APIs that are in .NET and C#, and it all just works. And we did Sam especially did a lot of work to make sure that worked. But that's just for completeness. That's not the reason we added dynamic.
Right. So the DLR seems to fit in here somehow. Can you talk a little bit about the role of the DLR? What is the DLR and what role does it play?
Well, so basically what happens when you have any dynamic expressions is the compiler will generate a bunch of code that will call into the DLR for you. And so, for example, if you were trying to make a call off of a dynamic object, we would go and call into the DLR, and we'd package up something that we refer to as a payload, which basically has if you're making, it has the operation that you're making, so it'll tell the DLR that, hey, I'm trying to make a call operation. For calls, it'll tell you what the name of the call is, how many arguments I've got, whether or not my arguments were passed by ref or by out and all that kind of stuff. And so really, it just encompasses the operation that you're trying to take. So the compiler will go and create one of those guys for you, pass it off to the DLR, and then the DLR will start going through a laundry list of things that it'll do. So the very first thing that it does is it checks the type of the object that you've got. If the object is a dynamic object, then it'll go and ask the object to go ahead and try to resolve that binding for you. So for instance, if you're programming against an IronPython object or an IronRuby object, for instance, those guys will be able to do their own dispatch for them. The next step it'll take, if that falls through and doesn't succeed, then it'll ask, is it a COM object? If it's a COM object, then it's going to go and call a special COM binder that will go and deal with, the iDispatch interfaces and all that kind of stuff for you. And then if that fails as well, then it'll fall back to reflection and basically use reflection to figure out what the overload resolution ought to be and which methods to call and all that kind of stuff.
And syntactically, how does it look in the C# language? How do you know you've got a dynamic object? What is the syntax for designating that you're working with an object that's dynamic?
So we've introduced a dynamic type, and it's really just syntactic sugar for object. You essentially use the keyword dynamic instead of object when you declare your variables or when you have return types or when you have parameter types and all that. And basically what it tells the compiler is it tells the compiler to not do any static, well, not do most of the static type checking that it would do. So, if I were to declare my object as a dynamic object, any subsequent member accesses off of it won't be checked by the compiler, and it'll just package up a payload, like we mentioned earlier, it'll package up that payload that describes the operation that you're trying to do and send that off to the DLR and have that bound at runtime.
And in response to that question specifically, like what syntax allows you to know that you're dispatching dynamically, the answer is that there isn't any. And that's sort of an important design feature, that there's no syntax. You can't look at the syntax of an expression and say, oh, that's going to be dispatched dynamically, because it depends on the types. And dynamic really is, it is a type in the language. And it has a very different behavior than most other types in the C# language. And when you have dynamic expressions that are subcomponents of larger C# expressions, then you get dynamic dispatch. And it has nothing to do with the syntax. So we originally, a long time ago, this feature went through a lot of iteration, and a long time ago we did have, we considered using various syntaxes. Is that the right plural?
Sure.
Syntaxes. We considered using syntax to denote a dynamic dispatch because of what you said. C# is statically typed, and people who are using it expect a statically typed language, and it seems like, well, maybe there should be a special syntax so that when you're doing it, you don't just accidentally go dynamic and have things evaluated at runtime. But that is, it turns out, very complicated. Changing the syntax of the C# language is one of the most expensive things that we can do when we're designing language features. And also, it makes your code look like a mess. It doesn't make your code look like C# anymore, depending on how we did it. And there's adding tildes here and there and question marks, and there were a variety of things that we considered doing. But it's important that when you're using dynamic, you're writing C# code. You're not writing some variant of C#. You're writing C# code, and you have your dots, and you have everything is the same. There's no syntax. Except that now you can say dynamic, and it's a type. But that's not a syntactic change. We just added sort of a built-in type.
A new type. But it's possible, for instance, calling a COM object, that dynamic objects will be created and you'll never know it. You'll never have used the keyword dynamic in any
There is, well, I mean, you can also, it's not just COM objects, but you can import types. I mean, these dynamic types, if you have a method that returns dynamic, or a field of type dynamic or whatever that happens to be in metadata in some assembly that some library introduced, you import it and you use it, then you have a dynamic thing and you're going to get dynamic dispatch, and you never said dynamic. And the same thing is, there's a special consideration for COM, which is that COM interop assemblies often use the type object to mean, it depends on, there are a lot of details with marshalling, but the CLR knows that object means sometimes a variant or interface pointer, and they get marshaled specially, and so an object could hold anything. And in order to allow us to dispatch against those things when we receive them from COM APIs, if you use the new, if you embed your interop types, you use the new C# 4 feature, which I'm not sure what we call it. Do we call it Nopia publicly?
I think maybe, I don't
Yeah,
know.
But if
Nopia,
in
yeah.
C# 4, if you link specially to your COM interop assembly, then all of those objects turn into dynamic magically, because we couldn't have gone to all of the interop assemblies that already existed and turned them into dynamic. So,
Well, let's hold off a little bit on the COM stuff, and then go back to the DLR for just a second here.
Sure.
So, how does the DLR fit in with the CLR? What's the relationship between the two of them?
So you can kind of think of the DLR as really just a set of libraries that we call. The CLR is, a real honest-to-goodness runtime that everything sits on top of. But the DLR really is sort of like a set of library functions that you're calling that just kind of do stuff for you. I'm sure the DLR team wouldn't like that explanation, but you can kind of think of it that way, right? It basically is a set of APIs that the C# compiler will generate code to call for you, and that set of APIs will do a lot of the dirty work for dynamic dispatch on behalf of the user. And so, some of the things that it'll do is it'll, like I mentioned earlier, it'll figure out a laundry list of what bindings we should try. It'll do things like cache the binding results for you, so that if you've got your dynamic dispatched call inside a for loop, for instance, you won't have to rebind it every time. It'll just it'll stash away what the overload resolution figured out, and all that kind of stuff. So the DLR really is a set of library methods that sit in between the user's code and the CLR.
And so in that sense, the DLR is like if you ask what is its relationship to what is the DLR's relationship to the CLR, is that like any other library, the DLR just sits on top of the CLR.
Right.
However, I think that the name DLR is sort of a clever hint that it does bear some resemblance to the CLR, in that the CLR came about to have a common environment in which to execute code in all these languages that could interop. And I mean, from the beginning, it's been a very common language runtime, right? It's language neutral, and it's a machine that works no matter where your assemblies come from and how you write them. And the DLR is tries to be the same thing for dynamic languages. So the DLR is the way that you that you execute dynamic semantics. And there used to be a lot of different ways, even in the .NET world, in the CLR, right? You have script objects that you can do things to, and you have reflection APIs that you can dynamically invoke things on, and you have COM interop, and the CLR does something special there, but it's still doing special things for iDispatch COM execution, and that's kind of dynamic and late bound. And all of these late bound things now, we can do them through one API. That API is the DLR. And the C# dynamic feature is the language view by which you, the C# user, see the DLR.
And you can kind of think of the DLR as really prescribing a set of guidelines that, if you want to participate in dynamic binding, then you need to subscribe to these things. So they have a set of standard actions that each dynamic object or each dynamic object model needs to implement in order for it to be, to be considered dynamic and for it to play well with other DLR languages. And so, things like, they have a set of standard operations that need to happen, like binding calls and binding binary operations and all that sort of stuff. And there's a standard set of APIs that you need to overload in order to play well with the caching mechanisms and all that kind of stuff. But exactly like Chris mentions, it's really just a common place where everybody can subscribe to the standard, and that means that everybody else who plays along can play with you once you've done that.
And we've been jokingly, in the same way that the DLR is kind of a name that was chosen to sound like the CLR. I think I don't know who picked the name, but we jokingly refer to something called the DLS. Which corresponds to CLS, which is sort of the minimum set of things that you actually need to really implement if you want to play well. If you want to, if you want to write a dynamic language, or you want to implement a dynamic object, and that's kind of, we're aware that when we are designing C# and we're implementing the C# compiler to generate these call sites, which do things and try to do things dynamically, we're sort of establishing the standard of how the DLR is going to be used, right? Because it's going to be used through the C# language. And so if you want to, be usable, then there are a lot of weird edge cases in the C# language, right? So if you want to be usable as a condition in an if or a while or whatever, then you have to implement a particular action, because that's what C# is going to provide to you. And so we've kind of jokingly called that the DLS, even though there is no such thing as the DLS, but
And physically, they're just a set of assemblies which ship with C# 4.0 integrated in with the code, or is it physically a separate download or something? How would the DLR?
DLR is in the framework. You don't have to download it.
You don't. It's built right in. So when you.
It's in system.core.
Yeah, in system.core, perfect.
And do you know how they distribute it otherwise? The DLR is also it's distributed and deployed with IronPython if you get IronPython separately, or IronRuby, and those are on CodePlex, and you can get the source and everything, and so you can see how it works. And I don't know at this point in time how that diverges from the DLR that's shipping in .NET 4, but when the DLR that's in .NET 4 is in System.core, and when it ships, then it's frozen, and that's the .NET 4 version. And I expect there to be, I expect Python and Ruby to ship a version that works with CLR4 and uses that DLR. But then there's also the DLR that ships with IronPython, and you can get the source for, and they're slightly different. And I don't know what the details are.
Yeah, no, that makes sense.
But as far as if you're a C# 4 user and you have Visual Studio 2010, then DLR's in the framework. No need to worry.
Cool. All right, so it seems like when we say the word dynamic, I'm listening to you guys talk, there's three different things that it could mean in a sense. It could mean we're implementing a dynamic language or working with a dynamic language like Python or Ruby. You're working with COM interop Office, or you're working with dynamic C# or other .NET objects and reflection. So there's three, it seems to me like there's three different branches. Does that make some sense? Yeah.
Sure. Yeah.
So let's dig in. I think we were talking earlier about the Office, so why don't we dig in a little bit into what role does dynamic play in Office? And you were talking some about that, Chris, earlier, describing how some of those calls resolve and what they do. So what role does dynamic play in Office, and how does it fit in? What is the C# 4.0 role with Office in general, I think is maybe a good place to start, and then focus on what it does that's dynamic.
Well, so one of the things that we recognize is a pain point with the Office object model, and with the COM object model in general, is that, like Chris mentioned, you return everything as object, but you kind of have this implicit contract that, like, hey, I'm really returning object, but I know that I'm only really returning one of, a couple of interfaces. And so users are having to write code where, they call an API method, it returns an object, they got to cast it, and then, dot off of that thing, and that returns another object, and they got to cast that and everything too. And that's, it's really, makes for really tedious and ugly code. And so one of the things that we decided to do this time around with C# 4.0 is to try to help simplify that. What happens under the covers is, as Chris mentioned, we basically annotate whenever you have a method that returns an object, we annotate it in the compiler as we compile against that. We annotate it with, hey, this is returning object, but it came from a COM thing, so I'm going to treat it as if it was returning dynamic. And because it returns dynamic, I no longer have to cast it to my interface in order to call an interface method off of it, right? Because it's dynamic, I can just say, well, I'm just going to dot off it, and I know the method name that I'm going to call off of it, so I'm just going to go ahead and call it. And as we mentioned, the compiler will then generate the code to call through the DLR, which will then call into the COM binder and take care of your dispatch for you, just like it would have statically.
Now, when you're working with an Office API, it seems to me from working inside the IDE, you get a lot of type information coming back. So, which is, I think, different than the experience that I've seen when I worked with Python or Ruby, where I just, whatever I type, if I do dot, I get no help from the IDE at all as to what's going on there. There's a thing, I think maybe a PIA or something that has something to do with how we get this information. Can you talk a little bit about that?
Well, the interop assembly, the PIA, is the CLR, the .NET World view of your COM type libraries, probably, because you probably use TLBM to get them. And so they are actually .NET types, and the runtime has a lot of special magic that it knows how to do the interop when you call those. You can think of those methods and those things as sort of being external, and that the CLR runtime knows how to get to them if you have those COM types on your machine. But even those, they're all strongly typed in the sense that their methods are really there, and but like Sam said, they often, I guess we say, you kind of run off the end often, right? You have, I have my Excel worksheet and I say dot something cells, and then dot something, and then I often get to a point where after a dot or two, I got to something that returned object. And once I got to something that returned object, I can't say dot anymore unless I just want like a two-string. And so then I have to cast it and introduce a bunch of parentheses and then do more dots if depending on how far you want to go. So these things are, they're strongly typed in the sense that we actually do have types for them, but they're weakly typed in the sense that often object is used when a more specific type is known to be used by the programmer. And also the com interop that we do dynamically is done by something Sam called the com binder, which happens at runtime. So whenever you use dynamic in C#, it's a clue to the compiler to say, I don't have any type information, or I don't have all the type information I need. I might have some, but I don't have all the type information I need. So I'm going to package this expression up and let it happen at runtime. And then at runtime, it's going to get figured out. And the thing that figures out com at runtime is, we call it the com binder, but you could call it the C# com binder. And it's similar to the VB com binder, but different. And it uses iDispatch and the com objects themselves to dispatch. So, a com object knows, a dispatch com object knows what the names of its methods are, and so all we have to do is say, hey, com object, here's a method, give me the dispatch ID for it, and I'm going to call you back. And that all happens at runtime. You don't need types. If you happen to have a com object in your machine and you had no type library and you had no interop assemblies, you could still dispatch to it dynamically. And that's one of the things that we do that allows you to not deploy interop assemblies now, among other things that we do.
So what is the no PIA feature? What does that do? You're describing it now, I guess, a little bit, but can you talk a little bit about what no PIA is?
So no PIA is, it's not really a language feature. It's more of a compiler feature. Basically what we want to do is we want to provide the ability to ship an assembly without shipping all the PIAs that come along with it. So if you're writing an Office add-in, for example, or an Excel add-in, you want to be able to write your small little add-in without having to ship the big, enormous Excel PIA onto the client machine. And so what we've done is we've done a bit of magic to just figure out what surface of the Excel PIA you're actually using. And so, if you're only using, one or two types and one or two methods on those types, we're going to collect that information and we're going to generate some hints to the CLR to basically let it know that, hey, we're compiling against these types and they really ought to look exactly like, the type on the Excel PIA that you had. And so, we're going to embed those interop types in our local assembly, and that's a little bit more technical than I'd like to get, but essentially we create types that look like the interop types, and we put them in your local assembly, and we give a hint to the CLR to say, hey, this should be equivalent to the type in the PIA. And then, at runtime, the CLR, when it gets the actual runtime type, it'll say, oh, well, hey, the compiler told me that, for your code, it should be equivalent to this Excel PIA object, so I'm going to go ahead and treat those guys as the same type. And so the no PIA feature basically lets you program against the PIA. So when you're compiling, you need the PIA there. You're going to program against the PIA, but the compiled assembly that you have will no longer have a reference to the PIA, and so you can ship without it.
Which means you just have smaller code. You're shipping much less than you used
Right.
to have.
Well, so your binary itself will be bigger because you're going to have, whatever limited portion of the PIA embedded in you, but you won't need to ship the PIA.
The PIA itself,
Yeah.
which can be megabytes of.
Right.
Yeah.
And no PIA is really orthogonal to dynamic. Dynamic could exist. They could exist without each other, but there
Yes.
happens to be this nice thing where they come together, and now you don't have to deploy PIAs.
Yeah, that's great. And you're right, we're drifting a little bit. I wanted to make sure people understood that. So when you're calling into Python, what's different besides, we've got at least an overview of what's happening when you call into Office now with Dynamic, and what happens when you're calling with Dynamic into Python or into Ruby? Is there any, from the programmer's point of view, does it seem any different, or from your all's point of view?
No.
Is it
Well,
pretty much the same?
from the compiler's point of view, the compiler has no idea right? When,
Right.
when you say dynamic,
Yeah.
you don't have type information, and you could stuff any object in there, and it could be a COM object, or it could be a Python object, or it could be a DOM object, or it could be a regular old CLR object, and the compiler just doesn't know. And so therefore, in the sense that the compiler is packaging up stuff to happen at runtime, all of that happens exactly the same, no matter what the object is. And then, of course, at runtime, different things happen. And at runtime, if it happens to be a Python object, in a way similar to the fact that a COM object knows how to dispatch methods to itself, Python objects know how to dispatch their own methods. And so we ask the Python object, hey, I want to convert you to a string. Could you please do that for me? And it does that.
And this is basically the DLR contract that we were talking about, right? Like, so in order for your language to play in the dynamic language space, you've got to be able to answer questions like, hey, I'd like you to convert yourself to this type. Can you go ahead and do that for me? And so Python has signed up to be a part of the dynamic language story or whatever thing that we're making. And so
or the dynamic language alternatively kind of came from Python, but
sure. And so it has, it's registered itself to figure out, hey, I can answer these questions that you're going to ask me, and so, so it plays along nicely with the DLR.
But in theory, if the name of the method was in Python was getString and you made a typo and left the G off, what would happen then at runtime? It would compile fine, right? Because the compiler doesn't know there's something wrong.
Right, so actually that's a really good thing to mention. Because you're going dynamic, and exactly like Chris said, because that compile time, we don't know anything about it, we're never going to give you any compiler errors for these things.
Unless your syntax is screwed up.
Right.
But
right,
if you have a misspelling, we won't know.
Right, exactly.
Right.
And so what will happen is at runtime, we'll ask the Python binder, hey, can you bind a method called etString, and it'll say, well, I don't have any method named that, and then the DLR will catch that and say, okay, well, Python couldn't bind it. I don't really know what else to do with this thing, so I'm going to throw an exception to the user telling you that, hey, there's no method named etString, and that's what you get.
And the hope is that when you get a message like that, you get more or less the same error message that you would have gotten if you were compiling this thing for real and it were a C# object and there were something wrong that we needed to tell you at that time.
Right. It's just you get it at runtime.
Yeah,
Right.
we hope that the error messages, of course, since generally for dynamic things, the object that we're dispatching to, the receiver, actually owns the dispatch and can do whatever it wants. I mean, it could do something crazy, but generally we hope that if the dynamic objects that we're dispatching to are sane, they give you something that's not a crazy error message that you're not going to know what to do with. It's going to look exactly like a compiler error.
Right.
Because we want it to be, we want it to be sort of logically a runtime version of the C# compiler, even though in a lot of cases we're not the ones, in fact in all the interesting cases, we're not the ones really doing the work at runtime.
Okay, so that's calling into Python, calling into Office. Then there's this third case where you can call dynamically into .NET, into or another C# object, where you're suddenly calling dynamically into a strongly typed world, it seems to me. Can you talk a little bit about what's happening there?
So this kind of comes off of exactly what Chris was just chatting about. This is the part that the two of us owned a lot, right? Because as you can imagine, we don't work on the COM binder stuff. We don't work on the Python and not any of those things. We work on the C# compiler, and so we were responsible for the C# runtime binder. And kind of what that means is, when you have a dynamic object, the DLR is going to say, hey, does this object know how to dispatch itself? If it's a Python object or Ruby or like a truly dynamic language object, it'll say yes. In the case of a .NET object, it's going to say no. Then the DLR will ask it, hey, are you a COM object? And again, in the case of a .NET object, it's going to say no. And so then the DLR will say, okay, well, those are the ones that I know of how to deal with. I'm going to go and fall back to the language binder and ask the language binder to go ahead and bind this thing. And this is really where we spend a lot of time working, and this is really where the semantics of C# really come into play. And so we have what we call the C# runtime binder, which much like the COM binder that Chris was talking about and the Python binder, knows how to dispatch objects. The difference is the C# runtime binder deals with .NET objects and primarily uses a lot of the reflection APIs to figure out what's going on. And so what we've tried to do is we've tried to essentially encode the same semantics that you would get if you were compiling compiling your operation statically in the runtime. And so, that means that overload resolution, if you were to pick one method at compile time, you should pick the same method at runtime. If you were to get one error message at compile time, you should hopefully get the same error message at runtime. And so that's kind of how the CLR objects get dealt with.
But all that takes place at runtime, not
Right.
at- yes.
Right.
And then what are use cases for this? Can you talk about times when you want to do this, have it call dynamically? And is it mostly a substitute for reflection, or an easy way to do reflection, or are there other cases where you might want to do
Well,
this?
it's definitely an easy way to do. I mean, we are using reflection in the C# runtime binder, and so you could have done whatever we do in the runtime binder to dispatch to the thing that you want to dispatch to. Although we do it a lot more complicated than you probably would. It turns out that overload resolution in C# and figuring out what an expression means is more complicated than you might think, and it's a lot of work, and we require a lot of data about all the arguments and the context and everything. And so we give you all that for free, like, are you in a checked context? We consider all of your conversions and all of your user-defined conversions and all kinds of things that you wouldn't do if you were dispatching via reflection yourself. But in another sense, it's a little bit more limited, because if you were using reflection yourself to call a method, you would call and invoke where you'd pass in a string, which is the name of the method that you want to invoke, or maybe there'd be a method info or something, and you could compute that name at runtime. You could ask the user to input the name of a method to call on an object, but you can't do that with us, really. I mean, not with the way that we use the C# runtime binder, because in order for you to use the C# runtime binder the way we intend it, you have to write C# code, and as soon as you've done that, you've got strings in your source file that you haven't computed. So we're a little bit more restricted. One of the reasons why we really absolutely need to do this is because whenever you call a method with a dynamic argument, we don't have type information for that argument. And therefore, in the general case, we can't determine which method to call, even if the receiver is strongly typed. And that's because there could be overloads. So if you have a method called m, and you have a method on the same class, you have a method called m that takes an int and a method called m that takes a string, and then you say, okay, I'm going to call x.m of d, my dynamic thing. Well, we don't know if it's the int or the string, and so we don't know. The compiler doesn't know which one to call, and so the only hope that the compiler has of getting this right in the general case is doing it at runtime. And in order to do it at runtime, we need to have the C# runtime binder. That's one of the big reasons why it's there. It's also, you can think of it kind of as completeness, right? It would kind of stink if you stuck a com object into your dynamic variable and you could call a method and it worked, and you could stick a Python object in there and call it and it would work, but you couldn't stick a regular CLR object. That would be very strange. I don't know. I mean, your opinion might differ as to whether or not we could actually get away with shipping something like that. But given that we need to dispatch methods dynamically, even when their arguments are dynamic, means that either we need to use reflection to dispatch against plain old CLR objects in every case, or we need you to cast all of your dynamic arguments, all of your dynamic things that you pass into something that would be a .NET operation. We need you to cast those to be the proper types. And of course, one of the reasons why we have dynamic is because we don't want you to write casts. And so, I don't know, that's my take.
One other thought is that you may be writing a .NET library that really is dynamic. Like Chris mentioned earlier, a lot of the DOM object models are kind of dynamic in that they return a set of they return objects, and really ought to be a set of possible interfaces that they could return. And in order to use them, you gotta again do the same com thing, where you gotta go and cast it to the right interface that you expect to return, and go call methods off of that and everything. And so those really are dynamic object models, even though they are written in as CLR objects.
And what is iDynamic object? What role does that play in this thing?
It has a new name.
Oh, I'm sorry.
A dynamic meta object now, I think.
Dynamic Meta Object Provider.
Provider, right.
Wow.
It's very clear. Much better than iDynamic.
And what is its role?
So it is basically the sign-up point for you to register your object as, hey, I play well with dynamic languages. If your object implements the we used to call it IDO, but IDMPO or something, whatever. If your object implements that interface, then when the DLR asks you, hey, do you know how to dispatch yourself? You're going to say yes, and then it'll forward all the dispatching over to your object instead of to the C# runtime binder.
That's how objects dispatch themselves.
Right.
And so to be an iDynamic Meta Object Provider means you're a dynamic object and you're going to be responsible for your own dispatching. And
Which means you need to implement certain parts of the interface.
Right.
yeah. And in the same way that when we import COM types, we do special things with object. You can think of that as being, well, we want COM objects to be dynamic, but unfortunately they already have these types and we can't change them, and so the compiler is going to treat them specially. You can think of the fact that COM dispatches dynamically as a similar special case where we would really like COM objects to be sort of logically, they are themselves iDynamic Meta Object Providers because those are the things that know how to dispatch themselves. But of course that's ridiculous because that's a notion that doesn't exist in COM. And so we make special adjustments and make sure that we can dispatch to COM objects even though they don't do that. They're the special case.
I'm not sure how practical it is, but it's fun to think of dispatching your own objects. There's this kind of desire to implement iDynamic.
I'm sure it's a lot of fun. That's the other half of, if we're talking about consuming dynamic APIs, then the other half of the equation is writing dynamic APIs.
Yeah.
And we don't have special language support to do that.
Right.
You can't say, class C is dynamic and blah, blah, blah. You would just have to implement this interface, and there are some shortcuts that you can take because there are helper classes that we're going to ship that make it a little easier. But that's how you create dynamic APIs as opposed to consume them. And you could, it's very easy to create, like the simplest dynamic API you could think of is like a property bag that just associates names with objects and then allows you to get those objects by saying .name instead of saying something like, .get of the string name.
Right.
Yeah.
And that's very easy to implement.
Yeah.
And you could do all kinds of neat things with that depending on what kind of story you want to put behind it and what kind of objects you're talking about. And that, for example, is how you might, you could write an iDynamic Meta Object Provider over any kind of, like the DOM is a great example, right? Where you have all this XML data and it's all structured in such a way that it's sort of naturally hierarchical with the containment of properties and
But you just don't know which node's going to come to you when, and this way you can dispatch them as you want.
right. Well, and also if you were creating strongly typed things, you couldn't put all the names there.
Right.
Because anybody could put,
Right.
if there's no schema, anybody could put any name they wanted there.
Yeah. So maybe I'm going a little far here, but when Anders gave his presentation last year, he had this thing with a REPL loop in it. Does that connect with dynamic at all? It's totally different.
No, that's it.
Yeah, that's
Sorry.
a different thing, yeah.
Right.
A lot of people are excited about that though, but that's not C# 4.
Totally different thing. Okay, great. All right, so what have we left off here? Is there anything else to say about dynamic that we haven't talked about, that we ought to discuss?
Well, there's a million things. The devil's in the details, and there are a lot of details with the way that we bind expressions, but they're probably not appropriate to talk
To do
about
this.
in a
Maybe you'll
video
write about
format
them.
where, we've made our best effort to make sure that dynamic binding is the same as static binding when there's an equivalence. But the question of when there is an equivalence and what we can, what are the edge cases that we couldn't encode because we lose data and blah, blah, blah. There are actually a lot of details.
One thing to say about this discussion here is that using dynamic and using calling into COM, calling into Python from the programmer's point of view is incredibly simple. You guys have made it absolutely easy. It's just as if you're writing it would be, it's exactly the intuitive code you would think you should be able to type.
You just write C#.
automatically. You just write C#, and it's
You have
exactly what it should look like.
They look like properties, they look like method calls, you can even do, we can, for each over a dynamic thing, and while, and using, and everything just works. And just make it type dynamic and stick in your object, and hopefully your code that looks and feels exactly like C# binds against that object, and that's the goal. We want it to be very, I guess, is transparent the right word?
Right, and it is. It's really easy to use. It's just interesting to talk a little bit about what's happening behind the covers, and that's what we've been doing here. And I guess maybe one more question I'd ask a little bit about is, can you say something to the old school C# programmer who's a little bit nervous about having dynamic types inside the language, and is what if they just say, I want strongly typed languages all the time? Is there something you could say to them to make them feel?
So certainly you don't have to use dynamic. Dynamic is an opt-in kind of thing, right? When you use an API that returns you dynamics, you can just as easily cast the return types to object and program statically against them and cast them to interfaces and do the same old thing that you would have normally done. And so certainly you can avoid dynamic if you want at all costs. One of the things that we should mention that we have been trying very hard to do is to ensure that the performance of this feature is quite good. Certainly there's going to be a little bit of a performance hit because you have all the DLR machinery happening, you have all of your stuff happening at runtime, all your bindings and stuff happen at runtime. But we've done a lot in terms of our performance analysis, in terms of figuring out a good caching strategy for things. We really do want to make this thing as seamless as possible for developers to transition to, and we really do want this to be just another tool in your toolbar that you can use that is not something that's that's a hindrance for you, or that's like an ugly spot in your code.
All right, you guys. Well, thanks so much for coming and talking, sharing all this information. It's really great stuff. So, Sam, Chris, thanks again for coming, and we'll go back and talk to you again later at some other point.
Okay.
All right, thank you.